A recent study suggests the universe is similar to your brain, only at a much, much larger scale. The brain's neural network contains about 86 billion neurons. The observable universe has at least 100 billion galaxies. Both galaxies and neurons have a similar structure. It's a complex web of nodes linking up long thread-like fibers. But in each of these systems, the fibers make up a mere 30% of the total mass, and the remaining 70% are either water in the brain or dark energy in the universe. The ways that galaxies and webs of neurons connect with one another are surprisingly similar. In both cases, the process follows the same physical principles. At the same time, some researchers claim the resemblance between the brain and the universe is only superficial. Your mind perceives tiny details and joins them, and then it comes up with a conclusion that has nothing in common with reality, like the brain is a mini-universe. In billions of years, the universe is likely to expand so much that we won't be able to see any stars in the sky. To turn Earth into a black hole, you'd have to squeeze it until it was the size of a marble. And if you wanted the sun to become a black hole, you'd have to compress it until it's no more than 4 miles across. A starburst galaxy is a galaxy that's forming tons of new stars at breakneck speed. It usually happens after 2 galaxies merge into one. While Earth has only one natural satellite, Jupiter is surrounded by at least 79 moons. In the universe, there are not only dwarf planets, but also dwarf galaxies. They have from 1,000 to a few billion stars. For comparison, the Milky Way galaxy is made up of 250 to 400 billion stars. A supermassive black hole 250 million light-years away from Earth hums the deepest sound ever detected from any object in the universe. It's 1 quadrillion, which is 1 with 15 zeros, times deeper than what the human ear can hear. Planet Kelt 9b is 670 light-years away from Earth. It's an ultra-hot Jupiter. Those are giant, scorching hot planets with a mass similar to that of Jupiter. On Kelt 9b, the heat is so great on the day side of the planet, it tears molecules apart. Any liquid floating in outer space forms itself into a sphere. It also happens in low Earth orbit. Our home Milky Way galaxy is more than 105,000 light-years across. All the planets of the solar system would fit between Earth and the Moon with some space to spare. Black holes spaghettify things. It happens when something gets past the point of no return. Then the black hole's gravitational pull starts to stretch this object in one direction and squeeze in another. The first celestial body that astronomers identified as a spiral was the Whirlpool Galaxy. Its long arms are made of gas and stars, and everything is sprinkled with fine space dust. When you're on Earth, you can only see 5% of the universe. A star coming too close to a black hole can be torn apart by its gravitational force. WASP 12b is a giant planet 1,400 light-years away from Earth. It's made up mostly of gas. Unfortunately, the planet is doomed. It orbits too close to its parent star. In about 10 million years, WASP 12b will be swallowed by its greedy sun. Our Milky Way galaxy and the Andromeda Galaxy, its closest neighbor, are going to meet in a bit less than 4 billion years. When they collide, they'll form one huge elliptical galaxy. One of Saturn's smaller moons, Enceladus, reflects almost 90% of the sun's light. It makes the moon one of the brightest objects in the solar system. But since it reflects sunlight instead of absorbing it, the temperatures on Enceladus's icy surface drop to negative 330 degrees Fahrenheit. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest. If you were standing on top of Olympus Mons, its slopes would be hidden by the planet's curvature. In our solar system, Mercury and Venus are the only two planets without moons. Scientists who are planning to send droids to Mars want to load the machines with lots of heavy equipment. The droids will also be built from stronger materials, all because of the relatively low gravity on the red planet. Everything on Mars is almost 3 times lighter than on Earth. Pluto's largest moon is half the size of the dwarf planet itself. This makes Charon, that's the moon's name, the largest known satellite relative to its parent size. There are 3 golf balls on the moon. They were launched during the Apollo 14 mission. Mathematicians claim white holes might exist, even though scientists haven't found one yet. If you came across a white hole, you wouldn't be able to enter it from the outside, but you'd see light and matter escaping from within. On our planet, one full rotation takes 1 day, but the Sun is so enormous that it needs 25 to 35 Earth days to make one rotation. The Moon is not a perfect sphere. It's shaped more like an egg because of the Earth's gravity. Spacesuits protect astronauts from huge temperature differences during spacewalks, from negative 250 degrees Fahrenheit to positive 250 degrees Fahrenheit. A neutron star gets born after a supernova collapses. After birth, it rotates extremely fast, about 60 times per second. But this rate can sometimes grow up to 600 times per second. In 2007, astronomers started to receive ultra-bright and ultra-strong radio signals. Named fast radio bursts, they were coming from somewhere billions of light years away. When astronauts are in space, they often see random flashes of light. They occur when cosmic rays hit the optic nerve in the eye. If you traveled around Pluto's equator, it would be the same distance as walking from Rome to New York City. If you visited GJ 504b, a planet located a mere 57 light-years away from Earth, you'd see that the planet is glowing. It's because of the heat left after its formation. The planet's color is a dull magenta, like a dark cherry blossom. Jupiter has the shortest day of all the planets in the solar system. It lasts just 9 hours and 55 minutes. Because of its fast rotation, Jupiter isn't a perfect sphere. It's a bit flattened. Venus has more volcanoes than any other planet in the solar system. There are at least 1,600 of them on the planet's surface, but most of them are extinct. Mercury has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. Nuclear pasta found inside neutron stars is believed to be the strongest substance in the universe. These noodles of neutrons can be 10 billion times stronger than steel. Some astronomers believe black holes might have no event horizon, aka the point of no return. Instead, there might be the apparent horizon. It can only trap stuff for some time. Later, matter or energy escapes, but in a different form. Each Apollo mission needed 15 spacesuits. Each member of the 3-person main crew needed 3 suits. One was for training, the second for flight, and there was also a backup suit, in case something went wrong with the flight suit. And each of the 3 members of the backup crew had 2 spacesuits, one for training and one for flight. Scientists believe Mercury might still have a partially molten core. It could explain why the planet has a magnetic field, even if it's just 1% as strong as Earth's. Dust storms on Mars are the most severe in the whole solar system. They can be raging for months on end. On planet Kepler 16b, which is 245 light-years away from Earth, not one, but 2 suns set over the horizon. The planet is as massive as our Saturn, but has a higher density. It takes 45 minutes to put on a spacesuit. After it's done, an astronaut needs another hour to adapt to new conditions. Earth-grazing fireballs are bright meteors that enter the Earth's atmosphere but then leave it again. Triton, one of Neptune's moons, orbits the planet backward. It's the only big moon of any known planet to do so. Triton is also gradually getting closer to Neptune. Experts think that, eventually, the moon will be pulled apart by Neptune's gravity, and then it'll form a ring around the gas giant. Dwarf planet Haumea, which is further from Earth than Neptune, is truly bizarre. It's orbiting in the Kuiper Belt, a donut-shaped ring of ice objects circling the Sun. Haumea has 2 moons, a weirdly elongated shape, and a day that lasts 4 Earth hours. But the coolest thing, the dwarf planet is surrounded by incredibly thin rings. They're likely the result of an ancient collision. It takes Neptune almost 165 Earth years to make one full orbit around the Sun. In other words, since the gas giant was discovered in 1846, it's only circled the Sun once.
Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These 2 phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, cause we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under two continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington Event, which happened way back in September 1859. It gave us a sneak peek of what the power of the sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, But this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington Event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't connected to a power source, they can't be affected by any surges.
Mercury, about 3.8 billion years ago. A huge asteroid is about to collide with the planet. Boom! Fragments are flying in different directions, along with the blast wave. When the dust settles, we see a crater almost the size of Lake Ontario. The most interesting thing here is the shape of the crater. It looks like a spider. A round body in the center, and a bunch of legs that spread out from the crater in different directions. But the strangest thing is that the spider's legs don't quite line up with the center. Scientists can only guess how such a landscape was formed. Some think that the picture of the spider appeared there much earlier, and the meteorite falling almost into its center was just a coincidence. But we still don't have a clear explanation of how such scars could have appeared on the surface of Mercury. Another mystery about Mercury is how it was born. One theory claims that the planet used to be Venus's moon, but over time, it succumbed to the sun's gravity. The star literally ripped Mercury away, and the little planet began orbiting it. What might prove this theory is the rotation periods of Mercury and Venus. Mercury is gradually losing its rotational speed. One day on this planet now equals 58 Earth days and continues to increase. At the same time, after losing its heavy load, Venus has started rotating a little faster. Another theory says that Mercury collided with Venus shortly after the appearance of the solar system. At that time, Proto-Mercury was slightly larger than the planet we're familiar with these days. But then, Mercury lost part of its crust after colliding with Venus. And a little later, Venus collected this debris. But scientists still can't come up with a definitive answer as to how Mercury was formed. Uranus, a gas giant, 18 Earth-Sun distances from our home. This planet seems calm compared to other giants, like Jupiter with its Earth-sized storms. And still, Uranus has something unusual to boast about. This dark spot, for example, was detected by the Hubble telescope in 2006. At that time, it was almost twice the size of Alaska. A few years later, bright spots appeared there. It turned out that they were methane clouds that moved across the surface of the planet at a speed of 300 miles per hour. But we don't know what exactly causes such storms on Uranus. Maybe we can solve this secret by looking at another mystery of Uranus. This planet rotates while lying on its side. If you look at the axis of our planet, you'll see that it's vertical and only slightly tilted. It's the same for most of the planets in our solar system. But not Uranus. Its axis is almost horizontal and pointed toward the sun. One of the poles of Uranus is fully illuminated at almost all times. The polar day on the planet lasts for 42 Earth years. When the tilt of Uranus's axis changes, the polar day starts on the other side of the planet. The other pole plunges into darkness for 42 years. This change of seasons can cause severe storms on the planet's surface. But why exactly Uranus lies on its side is unknown. Perhaps billions of years ago, the gas giant collided with several asteroids that were about to become a young planet. Such a protoplanet, similar in size and weight to Earth, could have tilted Uranus after crashing into it. But it's still just a hypothesis. Now let's go to Jupiter's moon, Europa. The big mystery here is whether there is life on this moon. Scientists don't deny such a possibility. All you see on the moon's surface is ice. The stripes you may spot are actually long, wide cracks. For a long time, scientists thought this moon was nothing more than a block of ice. But now, they think there might be liquid water inside. The core of Europa is heated by the tidal forces of Jupiter. This warm core melts the ice around it, so there really could be a huge ocean under the ice crust. Since water is the basis of life, different microorganisms could exist there. But we would only find out if we sent a probe there. We would have to drill through 24 miles of solid ice and start searching in an ocean twice the size of all water reservoirs on Earth. Look at Saturn's moon, Titan. It's the second largest moon in the solar system. It's 50% bigger than Earth's natural satellite. It's the only place in our solar system, other than Earth, where liquid water has been proven to exist. But the most interesting thing about Titan is its atmosphere. It's 250 miles thick. This distance is almost 40 times greater than the average cruising altitude of commercial planes on Earth. And it's 95% nitrogen. For comparison, Earth's atmosphere is 79% nitrogen, which means they're quite similar. The mystery is that no one knows how this atmosphere appeared there. One theory suggests that many years ago, meteorites hit Titan's surface almost non-stop. Massive rocks collided with the crust, raising the pressure and temperatures on the moon. Under such conditions, the ammonia in the air decomposed into nitrogen and hydrogen. The heavy nitrogen fell on Titan's surface, while the light hydrogen rose and flowed out into space. But some scientists dispute this theory. Another mystery of the solar system is the hypothetical star Nemesis, and whether it really exists. If you look at all the stars of our galaxy, most of them are paired, which means that two stars orbit around each other. Statistically, the Sun must also have a companion. So, some scientists have made an assumption that the largest mass extinctions on Earth were related to some mysterious object in space. They hypothesized that there was a red dwarf somewhere within 1.5 light-years away from the center of the solar system, and every approach of this dwarf star to the asteroid cloud disturbed these space travelers. Every time it happened, several asteroids began their journey toward Earth and caused a mass extinction. But this star hasn't yet been discovered, and many scientists question this hypothesis. Now let's look at the very edge of the solar system. A photon of light has to travel 1 year to get here. Scientists believe the Oort cloud exists in that area. It's a hypothetical region where tons of asteroids and blocks of ice gather into clouds. It's the furthest place where the sun's gravity still works. Presumably, this spherical cloud wraps around the solar system. This is the region where long-period comets are thought to originate. They fly all the way through the solar system and then return to the Oort cloud. This journey can take thousands of years. Even more exciting, there could be a gas giant called Tyche in that region. Some scientists say it might be 4 times the size of Jupiter. So far, no research has confirmed its existence. Although the Oort cloud is still considered hypothetical, some scientists believe that comets from that area are responsible for the major mass extinctions on Earth. Now let's go beyond the borders of the solar system. There, 1,500 light-years away from Earth, there's the closest to our home planet black hole. Black holes are the most mysterious objects in the universe. They're so heavy that they attract not only matter, but also light. Even more, they slow down time. Once something gets trapped in a black hole's gravity, it never escapes. Light and matter gradually settle near the event horizon and soon disappear into infinite darkness. Time flows differently here. 1 minute near a black hole can be equal to weeks on Earth. The biggest mystery is what exactly is inside a black hole. Some speculate that there's nothing but crushing pressure that destroys anything that gets there. Others say it might be a portal to another dimension or a wormhole to another place in the universe. If it was true, white holes would exist as well, as exits from black hole portals and wormholes. But no white hole has been found so far. Now, how about going to the hypothetical border of the entire universe? It's called the Eridanus supervoid. If you look at the map of the universe, you'll see an empty cold spot about 1 billion light-years wide. The entire Milky Way galaxy is only 100,000 light-years across. The main mystery is how the spot appeared. One theory says this void is the scar left by the collision of two parallel universes. Imagine that universes are giant bubbles, and one day, two of these bubbles collided. That's when the parallel universe ripped several galaxies out of our bubble. So far, this is the only explanation for how such a huge cold void could appear in our universe.